NENOMATICA, where mathematics meets YouTube excellence. Welcome! In this lesson, we will build an intuitive cheat sheet of logarithm properties. We'll move step by step with visual rule cards and quick numeric examples. Let's begin with the two most fundamental facts. First, the logarithm of 1 is 0. Second, the logarithm of the base is 1. Next, product and quotient rules. Product turns into addition. Quotient turns into subtraction, and a reciprocal flips the sign. A quick example in base 10. Log 10 of 5 equals log 10 of 10 over 2, which is 1 minus log 10 of 2. Power rules. An exponent on the argument becomes a multiplier. An exponent on the base becomes a divisor. Together, m over p appears. The root versions are just fractional exponents. Change of base and reciprocity are the power tools for switching bases. The product of log b of a and log of b equals 1. And log base b of a equals log base c of a over log base c of b. Two lovely exponential identities. First, n equals a raised to log base of n. Second, x to the log base I of y equals y to the log base of x. Let's lock this in with two quick worked examples. Example A. Simplify log base 2 of 8 plus log base 2 of 4 minus log base 2 of 2. Combine using product and quotient into a single log. Example B. Evaluate log base 9 of 3. Use change of base to log base 3 for intuition. Example. In this walkthrough, we will replicate the exact step order shown in the image, computing three values: log base 2 of 16, log base 10 of 100, and log base 10 of 1000. We will use only two rules: the power rule for logarithms, and the fact that log base of it equals 1. Problem 1. Compute log base 2 of 16. First, write 16 as a power of 2. Apply the power rule, pulling the exponent 4 in front. Now use the rule log base I of it equals 1. Evaluate to get 4. Quick challenge. Can you predict each next step for the base 10 problems before it appears? Problem 2. Compute log base 10 of 100. Write 100 as 10 squared. Apply the power rule. Use log base of it equals 1, then evaluate to 2. Problem 3. Compute log base 10 of 1000. Write 1000 as 10 cubed. Apply the power rule. Use log base of it equals 1 and evaluate the result to 3. Summary. We followed the exact structure. Express the argument as a power of the base, apply the power rule, then use that log base I of it equals 1. Our final answers are 4, 2, and 3. Example 1. We start with the expression log base 2 of the square root of 8. Now, we execute the steps in the exact recorded order. Next, write 8 as 2 to the power 3, still under the 1/2 exponent. Multiply the exponents 3 times 1/2 to get 3 halves. Apply the power rule of logarithms. Substitute. Use the identity log base I of it equals 1. Substitute that identity. And finally simplify. Great. Now, let's do a second example, keeping the very same step order and rule calls. Example 2. Our expression is log base 7 of 1 over 49. First, rewrite the fraction as a negative power. Then write 49 as 7 squared. Combine the exponents to get 7 to the power negative 2. Apply the power rule again. Substitute. Use the identity log base I of it equals 1. Substitute that value. And simplify to the final result. Summary. We carefully mirrored the original step order. Convert to exponents. Rewrite with the base. Combine exponents. Apply the power rule. Use the identity. And then simplify. Our final answers are 3 halves and negative 2. Example. Evaluate the base 10 logarithm of 4 plus the base 10 logarithm of 25. Let's open a working panel and copy the starting expression at the top. Step 1. Apply the product rule for logarithms. Log base c of a plus log base c of b equals log base c of a times b. So we combine the two logs into a single log of 4 times 25. Step 2. Compute the product 4 times 25. That is 100. Step 3. Rewrite 100 as 10 squared. Step 4. Apply the power rule for logarithms. Log base c of a to the x equals x times log base c of a. So we bring the exponent 2 down in front. Step 5. Use the identity log base a of equals 1. Therefore, log base 10 of 10 is 1, giving 2 times 1 in our expression. 10 of 10 is 1, giving 2 times 1 in our expression. Step 6. Multiply to get the final value. Here is the problem. We'll calculate 2 log base 10 of 4 plus log base 10 of 4. We'll label this as an example, and then proceed step by step. Step 1. Combine the like logarithmic terms. 2 of them plus 1 more makes 3. We apply the combine, like logs rule. So the expression becomes 3 log base 10 of 4. Step 2. Rewrite 4 as 2 squared. That gives 3 log base 10 of 2 squared. Step 3. Apply the power rule for logarithms, which says log base c of a to the x equals x times log base c of a. We'll bring the 2 in front and multiply it by the existing 3. The line becomes open parenthesis 3 times 2 close parenthesis log base 10 of 2. Step 4. Multiply the coefficients. 3 times 2 is 6. So the final simplified line is 6 log base 10 of 2. Therefore, following the exact order of steps, combine, rewrite as a power, apply the power rule, and multiply, we obtain 6 log base 10 of 2. In this example, we will follow the exact step-by-step algorithm from the image to evaluate the expression. Example: the problem is log base 3 of 54 minus log base 3 of 2. Step 1. Apply the quotient rule for logarithms. The rule says log base c of a minus log base c of b equals log base c of a over b. Using that, our expression becomes log base 3 of 54 divided by 2. Step 2. Simplify the argument. 54 divided by 2 equals 27. Step 3. Express the argument as a power of the base. 27 equals 3 to the third power. Step 4. Apply the power rule. The rule says log base c of a to the x equals x times log base c of a. So we pull the 3 down, 3 times log base 3 of 3. Step 5. Use the identity. Log base of it equals 1. Therefore, our expression becomes 3 times 1. Step 6. Multiply to finish. The value is 3. Recap. We used the quotient rule to combine the logs, simplified the argument, rewrote 27 as 3 cubed, applied the power rule, then the identity log base 3 of 3 equals 1, and obtained 3. Example: calculate 2 times log base 10 of 5 plus log base 10 of 4. Step 1. Use the power rule. Move the coefficient 2 into the exponent of 5x log base c of it equals log base c of a to the x. Step 2. Evaluate 5 squared as 25. Step 3. Apply the product rule. Log of a plus log of b equals log of a times b. Step 4. Multiply 25 times 4 to get 100. Step 5. Rewrite 100 as 10 squared. Step 6. Use the power rule again in reverse. Log base 10 of 10 squared equals 2 times log base 10 of 10. Step 7. Use the identity rule. The logarithm of the base equals 1. Log base a of it equals 1. Step 8. Multiply to get the final value 2. Recap. We used the power rule, then arithmetic, the product rule, rewrote 100 as 10 squared, pulled the exponent down, and applied the identity log base 10 of 10 equals 1. The answer is 2. Problem statement: 3 times log base 10 of the cube root of 4 minus log base 10 of 25. We will now reproduce each line exactly as in the provided solution. Step 1. Move the coefficient 3 into the logarithm as an exponent using the power rule. Step 2. The cube root of 4 to the third power is 4. Step 3. Difference of logs equals log of a quotient. Step 4. Rewrite 4 over 25 as the square of 2/5. Step 5. Apply the power rule in reverse to bring the exponent 2 out in front. Final line. Example 2. The expression is log base 27 of 3 times log base 3 of 27. We again follow the exact 2-line solution from the image. Step 1. Use the change of base formula to base 10 for both factors. Step 2. The two fractions are reciprocals, so the product equals 1. Final answer. Step 2. The two fractions are reciprocals, so the product equals 1. Final answer. Recap. We strictly followed the image steps. For the first problem, we used the power rule, simplified the exponent, applied the quotient rule, recognized a perfect square, and used the power rule again to get 2 times log base 10 of 2/5. For the second problem, we used change of base and direct cancellation to get 1, and direct cancellation to get 1. Example. Evaluate the expression. Log base 3 of the log base 3 of the log base 2 of 8. We will mirror the written steps exactly. Step 1. Express 8 as 2 to the third power. We are using the power of the base idea. Step 2. Apply the logarithm power rule. The exponent 3 multiplies the logarithm. Step 3. The logarithm base 2 of 2 equals 1. Step 4. Multiply 3 times 1 to get 3. Step 5. The log base 3 of 3 is 1. Step 6. The log of 1 in any base is 0. Example. Now evaluate the product of logarithms. Log base 3 times root 3 of the 5th root of 5 times log base root 2 of 9 times log base 25 of 8. Step 1. Rewrite each base and argument using exponents. 3 root 3 is 3 to the 3 halves. The 5th root of 5 is 5 to the 1/5. Root 2 is 2 to the 1/2. 9 is 3 squared. 25 is 5 squared. And 8 is 2 cubed. Step 2. When both base and argument are powers, use the rule log a to the m of b to the n equals n over m times log base of b. Step 3. Simplify the fractional coefficients. Step 4. The chain 8 is 2 cubed. Step 2. When both base and argument are powers, use the rule log a to the m of b to the n equals n over m times log base of b. Step 3. Simplify the fractional coefficients. Step 4. The chain product of logs collapses to 1. Log base 3 of 5 times log base 5 of 2 times log base 2 of 3 equals 1. Step 5. Multiply the coefficients. 1/5 times 2/3 times 4 times 3 halves equals 2. Therefore, the value of the product is 2. To summarize, example, we begin with the first expression. Step 1. Use the product rule for exponents. A to the power m plus n equals a to the m times a to the n. Step 2. Apply the power rule for logarithms. N times log base 10 of a equals log base 10 of a to the n. Step 3. Since 16 to the 1/2 is 4, and 10 raised to log base 10 of 4 equals 4, we simplify inside the square root. Step 4. Multiply 100 times 4, and take the square root to finish. Example. Now we work through the logarithm expression. Step 1. Use the power rule to move the coefficient inside, as an exponent. Step 2. Square the fraction to get 25 over 81. Step 3. Combine the first two terms using the quotient rule for logarithms. Step 4. Now use the product rule to combine the remaining 2 logs into 1 log. Now use the product rule to combine the remaining 2 logs into 1 log. Step 5. Simplify the fraction to 2, and we are done. We will replicate the steps exactly as shown. 1 over log base 12 of 2 minus 1 over log base 3 of 2. Step 1. Apply the reciprocal identity. 1 divided by log base I of b equals log base b of a. That turns each fraction into a log with base 2. Step 2. Same base subtraction converts to a quotient inside a single logarithm. Step 3. Simplify the quotient 12 over 3 equals 4. Step 4. Rewrite 4 as 2 squared. Step 5. Apply the power rule for logarithms. The exponent comes down as a factor. Step 6. Log base 2 of 2 equals 1, giving the final value 2. Example 2. Keep the same order and wording as in the provided steps. Log base of z divided by log base ab of z, with a greater than 0 be greater than 0, and z greater than 0. Step 1. Replace 1 over log base ab of z with log base c of ab. Then multiply. Step 2. Swap the factors. This does not change the value. Step 3. Use the change of base chain. Log base x of y times log base y of z equals log base x of z. Step 4. Split the product using the sum rule for logarithms. Step 5. Log base of a equals 1, so the result is 1 plus log base of b. Recap. From the image text, we preserved the original order of steps exactly. We used the reciprocal identity, the difference to quotient rule, the power rule, and the change of base chain to reach the final results. Here is the problem. Step 1. Factor the 75 inside the logarithm as 3 times 5 squared. We use factoring of the argument. Step 2. Apply the product rule for logarithms to expand log base 15 of 3 times 5 squared into a sum. Product rule. Step 3. Use the power rule to bring the exponent 2 down in front of the logarithm. Power rule. Step 4. Distribute log base 15 of 3 across the parentheses. Distributive property. Step 5. Recognize the pattern as squared plus 2, b plus b squared. It factors as the square of a plus b. Perfect square trinomial. Step 6. Combine the sum of logarithms back into a single logarithm using the product rule in reverse. Product rule in reverse. Step 7. Multiply 5 times 3 to get 15. Step 8. The logarithm of the base itself equals 1. So log base 15 of 15 is 1. Identity. Step 9. 1 squared equals 1. Step 8. The logarithm of the base itself equals 1. So log base 15 of 15 is 1. Identity. In this example, we will evaluate a telescoping sum of logarithms. We'll follow 3 simple steps. Combine using the product rule, simplify the product by cancellation, and finally evaluate the remaining logarithm. Step 1. Use the product rule for logarithms. Log base b of x plus log base b of y equals log base b of x times y. So our sum becomes a single logarithm of the product of all those fractions. Step 2. This is a telescoping product. The 2 cancels, the 3 cancels, and so on, leaving only n over 1. Let's visualize the numerators and denominators aligned. As we draw cancellation slashes, everything except n and 1 disappears. Therefore, the product equals n, so the expression is log base n of n. Step 3. Use the identity. The logarithm of the base equals 1. Therefore, log base n of n equals 1, which completes our proof. Example. Problem. Compute log base x of the cube root of x times the square root of x times the square root of x. Domain x greater than 0 and x not equal to 1. Step 1. Write the original expression. Step 2. In the image, simplified the innermost square root. Minimal correction, x times square root of x equals x to the 3 halves. So we write log base x of the cube root of x times the square root of x to the 3 halves. Step 3. Simplify the middle square root. The square root of x to the 3 halves is x to the 3/4. Step 4. Combine the factors inside the cube root. X to the 1 times x to the 3/4 equals x to the 7/4. Step 5. Take the cube root by multiplying the exponent by 1/3. That turns x to the 7/4 into x to the 7/12. Step 6. Apply the logarithm power rule. Pull the 7/12 down in front. Step 7. Because the base and argument match, log base x of x equals 1. Step 8. Multiply to get the final value, 7/12. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.